hello, this is Tony, and I'm actually just creating this video so I have a copy of it in the future sometime. For the past 2 years, I've unable to run my server to connect to MC-LOL because MC-LOL has suffered some problems. However, it works now, and I'm just going to make this video so I'll have a copy of it. You can hear my server running in the background. It's really loud. I think it's 60 decibels or something. It's equivalent to sitting next to a vacuum cleaner. So to show you what I built, sorry, it lags a bit because I'm actually recording this. To show you what I built this 2 years ago, by the way, so I had no idea how computers worked, and actually still don't, but I know a little bit more than 2 years ago. So this is what I built 2 years ago. It's actually a 3-bit add-on, and in the year 7 to 10 syllabus, students learn about electricity with the analogy of water. Well, why not build a little processor that runs on water? Technically you can build out of anything. You can build out of dominoes if you really wanted to, like Heron of Alexandria, who actually built a computer out of rope and sticks. So you can build out of anything, but using a water analogy, this is how you would add 3 digits. So this is a diagram of a 1-bit adder, and what I'll be doing is using ripple carry, and putting the 1-bit adders in series. This is not the most effective way of doing this, but if you look at the circuitry, it's actually really complicated, and I don't want to do estimations such as look-ahead carries, etc. So I think that's pretty straightforward. So I named this Earth in response to my other computer. I'll show you my other one a bit later. So this is Earth in response to something called Deep Thought, and if you know where that's from Hitchhiker's Guide to the Galaxy. So tomorrow's technology today, Earth, the 3-bit processor, next generation, bringing the future to you. And that is the truth table, very large truth table, 3 bits, and this is the instructions on how to operate this. Over here we have the sand, which tells you when the calculations are finished, and over there is, I don't know what you call that, but where the data gets shown at the end. But we don't have anything, or have no use for that at the moment. So what we're going to do now is take the elevator. Oops, I'm actually floating, by the way, so I don't actually have to do this. Take the elevator up until this area, and this is what I call the console. Whoops. It's a bit weird. So we need to put lava back in, otherwise I have no fluids to work with. If I'm correct, this is how it works. Okay, lava, let's go fast. Good. So now I want to put a brick here. Okay, I put a brick here. And then I want to make this console operational by activating it with an air flood. So now I have a process which supplies essentially an infinite amount of energy, but that doesn't really matter. And I'll break this, so now the console is in a loop. Turn the air flood off. I forgot most of these commands, by the way, I'm really sorry. I just know I did them just one hit, and now I'm kind of stuck. Okay, I'm going to stop floating, and I'm going to head over here to this grey block, which I call the terminal. Facing this way, you can input the first set of data. So what we're going to choose is any random number, 1, 0, and we're going to plus it to 1, 0, 1 or something. So something like that, anything you put in. Once you've done that, you hit this button, which is the enter button. I'm going to float again to show you the calculations occur. Oh, sorry, it's clouds. Okay, so now it's beginning to calculate. It's going through all these logic gates. Over there, the black thing, that's the buffer. This makes sure that all the logic gates fire in sequence. See how I organized it really nicely here like this? It's really nice. And I'll just show you some of the logic gates, how they're operational. Like this one, like that one. Okay, and yeah. So essentially what we're waiting for is this bit of sand to disappear. It will turn into glass. And when it's turned into glass, whatever answer is shown here will be the answer that the computer has finished calculating. So let's have a look at the truth table. 101 plus 110, or 101 plus 110 is here, and the answer will be 1011. So we're expecting 1011. And this is going to take a really long time because it's going to just keep calculating. And of course it's going to be very slow because, as you can tell, electricity moves a bit faster than this. Actually, a lot faster than this. But, yeah, I could speed this up, but I reckon this is just really beautiful. So going back to the 710 syllabus, using fluids, using water to explain how electricity functions, well, you could actually use the alpha version of Minecraft and just use the redstone wires. However, that is actually not educational if you think about it, because why would you use fake wires if you could use real wires? The purpose of a model is to demonstrate a specific concept. In this case, the concept that is being demonstrated is, in the conductor, the electrons are moved by an electric field. However, in this world, there is no electric fields. So what have I done? Instead of using an electric field to move particles, I have essentially moved the particles using a gravitational field. That would mean that everything that moves in the z-axis is the potential difference. Does that make sense? So the projection of this 3D image onto this 2D surface down here, this is why I've labeled it microchip, you'd expect it to be a flat thing like this. Microchip. But actually, there's another dimension right here. Of course, this is not actually true of the electric field, but it's just an analogy. And it's cool because the gravitational potential difference is the actual potential difference. So here we've seen that it's finished calculating, the sand's disappeared. So we look down here and we see it's 1011. And that is the end of Earth. Before I finish this video, I'll just show you why this is called Earth. It's actually called Earth in response to this other crappier computer called Deep Thought. So this is a concept one. It's a 2x2. This is its truth table. Very basic. It took me a while to build because I have no idea how logic gates worked at all. And I'm not going to use it, but it's kind of like in the museum, right? As you can see, that's my favorite equation. I've been in love with it for 2 years. Don't Panic, the front cover of Hitchhiker's Guide to the Galaxy, instructions, a half adder, not a full bit, but 1 bit anyway, quantum technology, because just face it, consumers love it when you add the word quantum to things. Deep Thought, right? The answer to the universe, it's 42. Help. And that concludes the end of my video. Thank you for watching, and I'll see you guys next time.